Newton gave calculus motion. Leibniz gave it symbols. Euler gave it a universe of functions and series. But then came a question that every powerful idea must face. Why does it work? Not just, why does it look right? Not just, why does the picture feel true? Why is the step justified? This is where Augustin-Louis Cauchy enters the story. Cauchy did not come to remove beauty from calculus. He came to protect it. For a long time, mathematicians used infinitely small quantities, moving points, curves, and series with extraordinary success. But success alone was not enough. Calculus needed a way to say, this is not only beautiful, this is controlled, this is justified. The first great idea is the limit. A limit is not merely a number that a graph seems to approach. A limit is a promise of control. It says, make the input close enough, and the output is forced to become close enough. That word matters. Forced. A drawing can suggest the truth. A limit begins to prove it. Continuity also needed a clearer meaning. Before rigor, a smooth-looking curve could feel continuous simply because the eye accepted it. But Cauchy wanted more than the eye. Continuity means that a small change in the input produces only a small change in the output. No sudden jump, no hidden break, no surprise when we zoom in. Then comes the derivative. A tangent is not just a line that looks right. It is the limit of secant lines. One point stays fixed, another point moves closer. Every secant gives an approximate direction. As the moving point approaches the fixed point, the directions settle. The final settled direction is the tangent. That is why the derivative is not only a slope, it is a limiting process. The same need for control appears in sequences. A sequence converges when its later terms gather around one destination. At first, the terms may move widely, but later, they begin to settle, and Cauchy's idea goes even deeper. Sometimes we can tell that the later terms are becoming close to one another before we clearly name the destination. That is the Cauchy spirit. Infinite processes must not merely continue, they must settle. This matters because calculus is filled with infinite things. Infinite sums, infinite approximations, infinite series. Euler showed their power. Cauchy asked, which of them can we trust? A series is not trustworthy because its first terms look nice. It becomes trustworthy when its partial sums settle. So, Cauchy's role was not to make calculus less beautiful. His role was to make its beauty stable. Before him, calculus was powerful. After him, calculus had to explain itself. Limits became the language of control. Continuity became a rule of behavior. Convergence became a condition for trust. But even this was not the final word. The next chapter goes sharper. Weierstrass would take the intuition of limits and turn it into the epsilon-delta language of modern analysis. Cauchy taught calculus how to justify itself. Weierstrass would ask it to justify every step from the ground up.